Hello friends, welcome to my YouTube channel. Let's learn together. In the previous lecture, we have learned some problems related to cantilever beam using concentrated load and uniformly distributed load. And today we are discussing some problems related to uniformly varying load. If you are missing my previous lectures, then go to my description box. I will provide link in the description box and you will see it. Okay, now start the lecture. Let's take a cantilever beam having U.V.L, that is uniformly varying load throughout its section. Let's the intensity of loading at this point, that is at free end, is 0, and at fixed end, that is 10 kilonewton per meter. Let this end is A and this end is B, and we take the entire span is 5 meter. Okay, now calculate shear force and bending moment diagram of this beam. Now we will start it with calculating shear force value at each point. Shear force value at each point. First, we are calculating shear force in left or right of the section. Always we have calculated shear force at left and right of the section. First, shear force at B, just right, and then just left. I will recall the sign convention of the shear force is, if we take it anti-clockwise moment, then it is negative, and if you take it clockwise moment, then it is positive. Okay, now let's start it. At B point, just left, just right, means at this point shear force will be 0, and because there is no loading. At just right, sorry, just left, it is just right and it is just left. At just left, there is also no force, so because the intensity of loading is here 0, so shear force at just left is also 0. Now calculate shear force at point A, means at this point. Now take just right and just left of point A. At just right means at this point shear force will be how much? In case of uniformly varying load, we take loading intensity of loading diagram equal to area of the loading diagram. So here intensity of load equal to area of the loading diagram. So here our uniformly varying load, that is U.V.L, is acting in triangular shape. So here area will be half into base into height. So just calculate shear force at point A, just right. That will be the area of the loading diagram. That will be half into base into height. Base equal to 5 and height equal to 10. And now we come to the sign convention. Here about this point, this load gives which moment? This clockwise moment, so it will be positive. Here we can calculate the value of shear force will be how much? That is 25 kilonewton. Now at just left means at this point how much will be the shear force? This will be 0, because here about due to this loading there will be a reaction comes out in fixed end. There is no support in free end, so there is no reaction. But here it is the fixed end support. So here reaction will be developed, and the reaction will be equal to the amount of downward force, because it is upward force. The sum of upward force equal to sum of downward force. The RA will also be equal to 25 kilonewton. Now left, at just left, shear force will be 0. Now calculating bending moment. We are calculating bending moment always at this point, at the point only. No, not at the just left and just right condition. So we started at bending moment at point B equal to how much? At this point there is no force, so there is no loading. The bending moment will be 0. So bending moment at point A equal to area of the loading diagram, that will be intensity of loading into perpendicular distance about this point A. Here now how much the intensity of load? Intensity of load equal to area of the loading diagram in case of uniformly varying load. Okay, in uniformly varying load, intensity of load equal to area of loading diagram, that will be half into base, that is 5, into height, that will be 10, into now how much the perpendicular distance in triangle in its G will act its h by 3 distance from its base. Here it is the base and this is the height. Then the distance will be this much, that is h by 3, that will be 5 by 3. And now come to the sign convention. Sign convention will be how much? That it is a downward force, so it will be negative. Now just put the value in the calculator. We can calculate the value of moment, that is half into 5 into 10 into 5 by 3, that will comes out 41.67. okay, so 41.67 and the sign will be negative and the unit is kilonewton into meter. Now we draw the bending moment and shear force diagram, that is SFD and BMD. Okay, just redraw the beam for drawing bending moment and shear force diagram. Here it is 10 kilonewton per meter. This is point A, this is point B, and this is 5 meter. Okay. Now we'll draw shear force diagram. Okay. First, at point B, the shear force will be how much? The shear force will be 0. So here the shear force will be, we take the shear force will be 0. Now at point A, the shear force will be 25 kilonewton. Now here this is positive, so we draw it upward, that is 25 kilonewton. And now we draw it in which shape? It is parabolic, that is parabolic shape, because in case of uniformly varying load, the shear force diagram is parabolic. Shear force diagram is parabolic, and in bending moment diagram is cubic. Now draw the bending moment diagram. Here the point B, here the point A. At point B, the bending moment will be 0. Here we are calculating here. Now the point A, the bending moment will be minus 41.67. So just mark a point at point B, that is minus 41.67. And now we connect it cubically. Just connect it in cubical manner, that is negative. Okay. And it is BMD and its shape is cubic. So x is q. We denote it in x is q. Here it is x is square. Now move to our next problem using all types of loading. Okay, we are learn using only UDL, only UVL, only concentrated load. Now we are taking a beam which carry all types of. Let's draw a beam which carrying all types of loading. Let's here it is a point load, that is 10 kilonewton, and a uniformly distributed load, that is 5 kilonewton per meter, and a uniformly varying load at this portion only, and this will be how much? Let this will be take 5 kilonewton per meter. Okay, this is A, this is B, C, D, E, F. Now just draw shear force, and question is draw Question is draw SFD and BMD of the beam. Okay. Now we are calculating shear force. Okay. Just shear force at point B. We are starting from this point. Shear force at point B, just right, just left. Okay. At point B, just right, it will be 0. There is no loading. Just left, it will be how much? It will be also 0, because it is a very little intensity of loading is come in this beam, in this point, so we take it 0. Now shear force at point F, this is just right and this is just left. Okay, at just right means this, at this point how much the intensity of loading, this it is a triangular loading, so it will be what? Area of loading diagram. So half into base, oh sorry, I will I will forgot to mention the distance. Let it be 2 meter, 2 meter, this is 4 meter, this is 2 meter, and this is 4 meter. Okay, so now come to our topic. Sorry, shear force at just right of F point. Okay, here how much the intensity of loading? This is the area of the loading diagram, that is half into base, that is 4, into height is 5, so it will be 10 kilonewton. And here at this point this force gives clockwise movement, so it will be positive. Now at just left means at this point there is no further loading, so this load is continuing. So this is 10 kilonewton plus the 10 kilonewton, and it will be plus. Now shear force at point E, just right, just left. At just right means at this point there is no loading in this portion, so shear force will be same, so it will be 10 kilonewton. And at this point how much will be the shear force? This will be same, there is no further loading, so this is 10 kilonewton, and all are positive. Now shear force at point D, just right and just left. At this point just right means at this point we are calculating now shear force. Okay, so how much will be the force? Now here the intensity of this loading is how much? This is 10, so here we put it directly 10. And now this intensity of loading is how much? This is acting 5 kilonewton per meter, that is acting per meter run. So here the value will be what? 5 into 4, and the sign will be, at this point the force will be gives clockwise movement, so it will be also positive. So how much will be the total value? It is 10 and it is 5 into 4 equal to 20, that is 30 kilonewton. And at just left means at this point there is no further loading, so here the shear force value will be same, that is 30 kilonewton, that this will also positive. And now calculating shear force at point C, just right and just left. At just right means at this point in this portion, just look at in this portion there is no further loading, the shear force will be same, so this is 30 kilonewton. And at this point this is just left, at this point the value of shear force will be changed, that is how much? 30 kilonewton plus 10 kilonewton, there should be 40 kilonewton. And at this point, about this point, this force gives clockwise movement, so it will be positive, so I will plus it positive. Okay, or take it positive. Okay, this is 40 kilonewton. Now shear force at point A, just right, just left. At just right shear force will be how much? Same, in this portion there is no further loading, so shear force will be 40 kilonewton. And at just left this will be 0, because this same amount of reaction will be developed at this point, so here intensity of total loading will be 0 at just left of the portion. Now we will draw shear force diagram. Before we draw shear force diagram, let's calculate the value of bending moment. Okay. Now just calculate bending moment value. Okay. Now we are calculating bending moment. Okay. First, we are calculating bending moment at the point only. Only at the point, not at left or right of the section. Okay. So bending moment at point B will be how much? This will be 0. Now bending moment at point F. At point F, bending moment will be how much? The intensity of loading into perpendicular distance. Now and the force will be acting downward direction, so it will be negative. So minus how much the intensity of loading? That is half into 4 into 5, and now take perpendicular distance. About this point, how much the perpendicular distance? In triangular section, its CG will be act h by 3 from its base. If it is its base, then from this point to this will be h by 3. Total is h. So how much will this distance? This will be 2h by 3. Just put it. 2 into h value is 4 by 3. This is 2h by 3. Now just calculate this value. This value will becomes out how much? 4 into 5 into 4 divided by 3, 26.67, and this will be negative kilonewton in meter. Okay. Now we are calculating bending moment at point E. At point E, how much will be the bending moment? This intensity of loading into the perpendicular distance about this point. Okay. Intensity of loading is how much? Half into 4 into 5. Now we are calculating the distance. The distance we will taken from its CG to the point where we are calculating bending moment. It's from its point to this point. This will be 2h by 3, and now add this distance. We will take the total perpendicular distance to find moment. The distance will be how much? 2 plus 2h by 3, that is 2 into 4 by 3. This will be the bending moment at point E. Now calculate this value. This value will be how much? Half into 4 into 5 into 2 plus 8 by 3 minus 46.67 kilonewton into meter. Now bending moment at point D, means at this point how much will be the bending moment? Just follow the same process. Here due to downward force it will be negative. That will be intensity of loading is 4 into 5 into half into 4 into 5, and distance will be, this will be 2h by 3. The 2 into h, value of h is 4 by 3, plus we have to put we have to add this distance, because we are calculating bending moment about this point, and the distance will be this much. This perpendicular distance will be this much. Okay, so 4 plus 2, that is 6. 6 plus 2h by 3. H, we put the h value is 4. So 2 into 4 by 3 plus 6. Just put it. Now calculate the value of bending moment. This will be 86.67 minus 86.67 kilonewton into meter. Now calculate bending moment at point C. At point C, the value of bending moment will be how much? Sorry, we have forgot to add this loading. This U.V.L is also added. So now this add this loading also, that is half into 5 into 4. Intensity of loading is 5 into 4, and the perpendicular distance will be half of this span where our U.V.L is acting, that is 4 by 2. Just add it. I'm extremely sorry for my mistake. Now add also this minus This will be comes out to how much? 86.67. This will be also minus, and here minus 5 into 4 into 4 by 2 is 2. The total is minus 26.67 kilonewton into meter. Okay. Now calculate bending moment at point C. At this point, what will be the bending moment? Bending moment at this point C will be how much? Half into 5 into 4 into this distance will be this distance, that is 2h by 3, plus we have to add 2 plus 4 plus 2, that will be 6 plus 2, that is 8. And now add also this load, uniformly distributed load also, that is minus 5 into 4 into distance will be how much? The total load is acting at CG, so this distance will be h by 2, means 4 by 2, this is 2 meter, and plus add this distance also, because we are calculating at this point at C, so this is 4. How much will be the total load? Total moment will be this will be acting minus 186.67 kilonewton into meter. Now calculate bending moment at point A. Okay, bending moment at point A will be minus half into 5 into 4, and the distance will be 2h by 3 plus this distance, 2 plus 2 plus 4 plus 2. Okay, that is 4 plus 4, 8 plus 10, that is 2h by 3 plus 10, minus this loading, minus 5 into 4, this is the intensity of loading. Now perpendicular distance will be how much? 2 plus 2 plus this load is acting at CG, that is 2. 2 to 4 to 6. And now just add this force also. This will be how much? 10 kilonewton into perpendicular distance will be 2 meter. That is minus. We are taking negative sign because it is downward force there. 10 into 2. Total moment will be arises. Just give me 1 second. I will. This will comes out minus 266.67 kilonewton into meter. Now we draw shear force and bending moment diagram. Okay, first we are drawing shear force diagram. Shear force at B. This is point A. This is B. This point is point B. Shear force at point B will be 0. We are finding in 0. So just starting it from 0. Now shear force at point F, just write. It will be 10 kilonewton. So just at point F, this is 10 kilonewton. Let this point is 10 kilonewton. And we are drawing in which shape? This is parabolic, because in uniformly varying load, the shear force diagram is parabolic. Now at point F, just left, it is also 10. So here is this point. Now at shear force at point E, just right, this will be also 10. So just right, just left and just right, this is same, that is 10 kilonewton. So just connect it straight line. This is 10 kilonewton. Now draw shear force at point D. At point D, shear force at just right is 30 and just left is also 30. So here we mark a point that is 30 kilonewton and we connect it linearly. Here a uniformly distributed load is comes, so our diagram is linear. So here we connect it linearly. Now at point C, just write it will be 30 kilonewton. So just connect it with a straight line. This is 30 kilonewton. At just right it will be 40. So write shear force value at point C, that will be 40. So just raise it to value 40. Now and at point A, shear force value is 40 kilonewton. So connect it with a straight line, and now it will be 0. Here we draw shear force diagram successfully. These all are positive. Now we mark it, okay, for better appearance only. Now our shear force diagram will be completed. Now just move towards our bending moment diagram. Here we have calculating all the bending moment value here. Just put the value and draw the bending moment diagram. This point is A, this point is B. At point B, the value of bending moment will be 0. So just this point bending moment will be 0. At point F, the value of bending moment will be minus 26.67. And here uniformly varying load is acting. So our bending moment diagram will cubic. So just let this point, at this point, that is 26.67. This is negative. So connect it cubically. That is x cube. So it is cubic. Now at point E, means at this point. So here we draw at this point. Our bending moment value is minus 46.67. That is, let this point is 46.67, and this is also negative. So and here there is no further loading, so connect it straight line. 46.67, this is negative. Now at point D, our shear force will be minus 126.67. Let this point is 126.67. Here uniformly distributed load is acting. So our diagram will be parabolic. This is negative, so it is negative parabola. This is x square. Now at point C, our bending moment will be minus 186.67. And so here this is connected to the straight line. That is minus 186.67 kilonewton into meter. And now at point A, our bending moment will be minus 266.67. Just connect it with a straight line. 266.67, that is negative. Now we have completed drawing bending moment diagram. These all are negative. Here we have successfully completed drawing of shear force diagram and bending moment diagram with a beam which carry all types of loading. Okay, now we will meet in our next video. Till then, please support me and subscribe to my channel. Thank you.